So yeah, we can start off with the introduction. So Shivji and Saurabh Ojha is over here, and they are from the team Nutanix. And Shivji is the staff engineer, and Saurabh is the MTS2 over there at Nutanix. So both of them has a good contributions towards the open source, which Shivji have contributed towards Droid, and as well at the same time good contributions toward ClickHouse. They're going to be telling the various pull requests they've also merged over there, so contributed greatly. That's going to be covered in this session. At the same time, Saurabh has also marked his name as various speaker at various talks. And coming back to the numbers, we have Shivji that has given around 30 plus talks at the various seminars and the various sessions. So what better name to speak on this topic than him? And Saurabh would be guiding our way through the demo. So we are starting off with the event, and now Shivji and Saurabh, the stage is yours.
Thanks, Akshay. Let me go share the slides. Can you see the slides now, Akshay? Saurabh?
Yes, your slide is visible.
Okay, great. Um, so I am Shiv. Akshay has already done a wonderful introduction. Um, I'll keep it brief. My areas of interest are mostly around distributed storage, databases and streaming internals, and application architectures around using both of these. I am sort of working in the industry for around 13 plus years now. And over time, I have developed a deep interest in open source code bases, particularly databases and streaming technologies. Contributed to ClickHouse recently. Hope to ramp that up more. MySQL is somewhere I have written a lot of code. Apache Pulsar also I have fixed quite a few bugs, added a few features as well. This is my talk number 31. So I've been a regular speaker these days. Love to meet folks in the community and learn from them really. It just opens my eyes up to see how people are using the same thing that I use in completely different ways. No better way to learn than actually meet people in these conferences and meetups and discuss about these technologies and architectures. LinkedIn is where you can find me if you happen to sort of go through this talk later or look at the slides and have a question. Feel free to drop a text on LinkedIn. And then with me, I have Saurabh. Saurabh, you want to quickly introduce yourself?
Yeah, sure. So, hi guys, I'm Saurabh, and I'm also very much interested in databases, streamings, and Linux kernel. I made a few contributions to ClickHouse, Nats, Transferia, and I'm looking forward to increasing this. You can find me on LinkedIn.
Perfect. So now that you know your speakers, let's start with the agenda. This is what we will cover, and the flow will be as you see here. So we'll first set the stage, maybe a bit of a boring session. We will go through a bunch of definitions, but don't worry, it shouldn't be a lot. We will very quickly follow it up with a demo, so you see all those things that you hear in action. Then once we've gotten a feel of it, we will go through some architecture patterns that are commonly used in the industry. We will look at some real world use cases in the industry and where Iceberg fits, where, in my opinion, Iceberg is probably not the best fit. I typically like to understand where the technology, any new technology does not fit. Otherwise, it's a bubble where people think that it just works everywhere. I think we should know where one should not use it. Of course, technologies change over time. Maybe um, that becomes a good use case, or maybe I sort of am just wrong about it and I don't know something that you guys can tell me in the questions. Then we will go through the lay of the land today. Like Akshay said in the introduction section, ClickHouse is getting a lot of integrations, a lot of features with Iceberg, among others. And then we will go through um, a call for contributors. I'll show you that if you are like me who is interested in open source contributions, going through some database kernel codes and making some changes there, I'll guide you through the same so you can find a path and go try your hand. I genuinely think there was no better time to contribute to open source than it is now, and I'll hopefully prove that to you by the end of the session. And a few wish lists for future. Maybe if you can help us pull through these things. This of course the ClickHouse team doing a lot of work there, but if we can sort of make some contributions, sort of at least test those things out or document or in whatever we can help them, it actually goes back validating that open source is a great model. Let's start with the first definition, right? What is a lake house? You keep hearing about data lakes, you keep hearing about data warehouse, and then there is something in between called lake house. So if you are like me who's run database operations, or if it is something that interests you, you would know that running database operations is hard. Kubernetes is something that has gotten really popular, but Kubernetes also was first built for stateless services. Over time, stateful sets have taken off, but it still requires you to understand Helm. It still requires a database vendor to write nice operators that you can use. And operating with all these disks is harder, right? You know what would be amazing? If you can just dump all your data on S3 and it would just work, right? Or anything similar to S3 that understands S3 protocol. What would that give you? Well, you would have infinite storage and you would have amazing availability. So no time wasted in operations, just trying to do the best compute and make the best application, right? That would be wonderful. Once you have got a great storage system, you got to put some files on top of it, right? Because we are making a database. So Parquet and ORC are two really popular open source, well adopted and sort of quite permissive licensed file formats. Parquet is something that we generally use with Iceberg at our place. It's also more popular than and adopted than ORC as far as Iceberg is concerned, to my knowledge. Even for the lake houses, you have a bunch of choices. There's something called Apache Hudi, there is Iceberg, and then you have Data Lake from Databricks. And then you have Xtable and stuff where you can move things from one meta format to another table format. We will today concentrate mostly on Iceberg, but most of things that work in Iceberg, sort of you will find something similar in the other worlds of Hudi and Delta Lake as well. On the top layer, once you have defined exactly what that table format is and how the table looks like on top of the files, you can use a compute engine that supports Iceberg or the lakehouse technology of your choice, and you can sort of fire queries to either read or write data. Let's narrow it down and say we only want to care about Iceberg for this session. What is Iceberg? Well, it's a spec. I think most people don't get this initially. It's a spec. Think of it as a bunch of rules or APIs, all of these around Iceberg that you can see in the Apache Iceberg repo. It's not a database engine. It's not something where it's a built-in database engine solution where you get a URL and you just use it. It's not that. It's a spec, and it's really popular and well adopted across the industry now. A lot of the database vendors or streaming vendors are actually integrating this today. And that is why it makes for a great thing for a developer to actually go and look up to what these vendors are actually doing out there in open source. And you can have your compute engine of choice. Spark, for instance, works with Iceberg. Trino works well. DuckDB has some integrations. I think they are still working on making a nice write integration. The read really works well. ClickHouse also is doing a lot of work. I'll leave you with the sort of roadmap for 2025 at the end. You can see how much work has gone through, and there is still more to come. I'll talk a bit about that as well. AWS S3 tables is something that got a lot of eyeballs. So you can now have S3 buckets of type table, and you can get some managed Iceberg functionalities there as well. Well, we talked a bit about other things, but what does it give you in terms of features? ACID transactions, right? I have done a full talk on how you internally implement transactions in a single node, distributed node, and all of that when you go through my past talks. But what it really gives you is a framework where you can safely write code in an application and it should just work. You shouldn't have all that dirty data, concurrency issues, and all those things. You can time travel on data, so you can ask something around, 3 days ago at this exact time, what was the state of data for this table, for this row, or whatever, right? So you can go back in time and read the data. Schema evolution is important because nobody really knows in your business how it is going to change. Once it gets to users, the businesses change in different ways. Accordingly, the schema has to obviously evolve. Otherwise, it's very hard. You can make partitions and stuff, so you segregate data and store them nicely. So you can only read what you really have to read. You don't need read extra files or extra data in any way. And again, partition is something very, very core to supporting good read throughput as well as latency. So your partitions have to be right. If you have to change partition for some reason, then you can sort of change partitions, and Iceberg will support that evolution. Okay. So, and then let's talk a bit about why should you care about this, right? There are a lot of technologies that come and go. Why should you care so much about this? Why am I talking about this? Being so passionate about it? Because you can just dump data in one place, let's say one S3 bucket, and fire queries from all kinds of compute engines. You can also write from different places. We will show you that in the demo. So you actually see it running and believe it. There's a very strong ecosystem, and it's only growing right now. So there's a lot of adoption of Iceberg across database or streaming kind of vendors, and the community is really helping pull through this. You, in the past, when you heard about vendor lock-in, you actually thought of something else. You probably didn't think that these databases also have data in proprietary formats, right? So if you really want to change, you have to do the whole data migration from one database to another, which is not pretty. I mean, I can bet that no developer actually loves doing data migrations day in, day out. Like it's very tiring and error prone. Decoupling of storage and compute again is something that the industry loves after they have seen cloud. So you can finally have an architecture where all the data is on S3. You don't really have to manage storage so much. And then you can have compute of your favorite kind and run them completely separately. Like I said, we talked a bit about databases, but even streaming systems like Kafka has its own company, Confluent, having a service called Tableflow, which is based on Iceberg. So you can just sync Kafka to Iceberg kind of table storage. Apache Pulsar has something called Ursa Engine. Rising Wave also has some really good integrations around Rust, I mean, sorry. And in general, there is a lot of mind share. Next, right? We are saying we will talk about ClickHouse and Iceberg. So what the hell is this ClickHouse thingy, right? If you don't know about it already, it's a open source OLAP engine, very easy to get started. If you have worked with either a Postgres, MySQL, Oracle, SQL Server, any of those, or even DB2, ClickHouse for the queries at least seems very familiar. You have the same SQL, you have the same tables, rows, columns, databases, everything. So it's just so easy to get started. It's very popular. If you go to GitHub and check out the number of starts, it's amazing how popular it is. Open, Apache licensed, and very, very well adopted across industries. Some really, really big enterprises, even the modern enterprises, your LLM vendors, all of those use ClickHouse in some way today. Storage, compute, segregation. If you look at ClickHouse Cloud, there is a lot of good things that have been built recently, last 1 or 2 years. But on open source, it's still a struggle to run it well. It is quite coupled. With Iceberg now in open source, you can finally live that dream. And ClickHouse traditionally has been very good with integration. So the way they have written their whole code is something that's very extensible to read different formats of files, to read different types of tables. So you can just sit in ClickHouse and query CSV, obviously ClickHouse tables. You can sit and read a Postgres table. You can do all of those things, right? So Iceberg in that case is just one more extension. Again, I did a talk previously I'll leave the links at the end. You can go through that and see more about these. And ClickHouse has been supporting Parquet for quite some time. Now there are newer versions of implementation for Parquet to improve performance. Iceberg is there with a few basic features now, and we are looking forward to more. Recently, a week ago or so, we saw the rights PR being merged, and that's amazing because earlier when we did demos internally, we would use Spark to do writes and ClickHouse to do reads, and then we were not impressed. Now we can actually get rid of all of that, and we can just use ClickHouse to do reads and writes for ourselves. And then people who like to do something on Spark, who like to do an ML pipeline on top of Iceberg, they can use their own favorite compute engine as well. And last, right, I don't want to bore you with so much theory. So let's look at what is OLake, right? We are at this OLake event, so let's see. It's very easy on the surface. They have a wonderful CLI UI. You can just get a Docker container and run it and try it yourself. We haven't used OLake a lot. We know a bit about it, so we for the demo said, let's see if we can get OLake working for the demo, and it was like a charm. It just worked very, very nicely. So what is OLake again? It's a CDC tool. Think of destination being Iceberg, and then you can stream data from, you can either take a full MySQL table and dump it into Iceberg using OLake, or you can do the same with Postgres or MongoDB, and that too at ultra fast throughput. You can see on their website the benchmarks that they have done. It's very lightweight, no Spark, Flink, all of those hard to run things required. Supports both full load, told you, or you can take the change events, and then you also have schema evolution supported, built on back of Iceberg schema evolution. So with all of that, I think you have read a lot of theory. I'll actually hand over to Saurabh to take you through a quick demo, and then keep the questions flowing if there are any. So I'll stop sharing. Saurabh, you want to go ahead and start sharing and do the demo?
Yes, so I will start with the demo. By the way, this demo you can run on your own PC as well. You just need Linux or Mac OS, and if you can run Docker, you should be able to run this demo. You can find the link for it here. So going ahead. So just before starting with the demo, I'll quickly show you all the components that we have here. We have a compute layer where we have different kinds of engines through which we will be reading the Iceberg tables. We have ClickHouse, we have Spark. MySQL to OLake will be showing you how we can use it and how CDC works. For storage layer, we are using MinIO. You can use any S3 compatible storage. And for the Iceberg catalog, I am using the default Iceberg tabular implementation of the REST catalog. So one key thing, if you can take away from this demo, is the ease of use and interoperability between the engines. I'll show you how we are able to write to the same table using different engines. This is not something that you can do very easily because every database has its own proprietary format. So this is pretty cool. So in the interest of time, I'll quickly show you what we have on our object store as of now. I just have, I hope the screen is visible. Is it visible? Yeah, I think it is visible. So I just have a Parquet file here. Well, I'll show you the use of it later. So yeah, let's get started with the demo. Flow one that I'm going to show you is will create a table on our object store through ClickHouse and we'll write to that table from ClickHouse. So ClickHouse recently introduced Iceberg writes, so we'll be using that. So I am already logged into my ClickHouse client, and I'll quickly show you the tables that I have. I already have a table preloaded in my ClickHouse database. By the way, this is in ClickHouse native proprietary format. I'll quickly show you the count of rows. So there are around 16, 17K rows in this table as of now. So yeah, let's get started with the demo. Since all these features are experimental as of now, we'll have to enable a set of experimental features in ClickHouse. These are the three that we need to enable to use Iceberg for reading and writing. Allow experimental inserts, allow experimental database Iceberg, and writing full path in Iceberg metadata. Now that I have enabled these experimental features, I need to create a database which would connect to my object store and it should connect to my REST catalog. So this query does that. We are going to use data lake catalog engine for it. This will be powering our reads for Iceberg. Now that the database is created, and I don't think we have any tables in that, so you don't get any tables here. Now what we are going to do, just before that, I'll quickly show you what our object store looks like. Warehouse REST, we don't have any tables and namespaces as of now. Now I'll be using ClickHouse to create a table and the data and metadata Iceberg table, and the data and metadata of that table would reside in this object store. So this is the table that I'm going to create. If you see here, I am going to use the Iceberg S3 table engine, which supports writes to ClickHouse, writes to Iceberg from ClickHouse. I select the catalog type, warehouse, and all the other parameters which are required. Yeah. So what happens when I do this? So visually, what you can see is there is a new namespace being created weather, and within it, there is a new table being created weather. So this is how Iceberg naming convention works. You have namespaces and then you have tables inside it. This is pretty much similar to what we have given here, demo.weather.weather. Since we don't have any data in our table as of now, we only have a metadata folder with two metadata files. These are Iceberg metadata files. Moving ahead, we can quickly see this table can be now read from our demo database that we had created earlier. So this is the table, and we can even describe this. So if you see, these are all the columns that were created. Yeah. Moving ahead, let's try to insert one row into this table through ClickHouse Iceberg Writes and see what happens. So I have inserted one row, and you can quickly see the count in the table. It's one. And by the way, I just mentioned there is no data directory here as of now. But now, since we have inserted a row, we will have some data in the Parquet format in your data directory. And in your metadata directory, a few more files would have been added. This is how Iceberg actually does writes on your object store. So if you want to learn more about it, we'll share some links for that. Yeah. So this is a very powerful integration. Now that we have the ability to insert rows or write to a Iceberg table through ClickHouse, it unlocks a whole new way of writing to the table. For instance, you could read a CSV file and you can dump the data from that directly into your Iceberg. In this case, what I'm going to showcase you is the weather database that we created earlier. We are going to dump all the rows from that to our object store. So this is the query for that. I am inserting into this table, and I am selecting everything from my ClickHouse proprietary table that we created earlier. So just to quickly verify if it worked, we are going to see the count of rows. And as you can see, the count of rows has increased, and there were around 16,743 rows in this proprietary table earlier. And this is really powerful because now you can use different kinds of ingestion techniques, and you can write to your Iceberg tables from within ClickHouse. You don't actually need to write a separate application and read rows from ClickHouse tables and then dump it to Iceberg. Yeah. So that is one thing. Since I have emphasized a lot on interoperability of engines, let's quickly look at the flow too. So we have a Parquet file lying over here in my object store already. We are going to write this, whatever content is present in this file using Spark to the same Iceberg table that we created through ClickHouse. So if you see, I'll be fetching the Parquet file and I'll be instructing my REST catalog to write it to my Iceberg table. Let's see how it works. So I'll quickly exec into my Spark container. And by the way, Spark also has access to this object store. So I have provided the credentials here. That is how it is going to fetch the Parquet file and insert everything into the existing table. So I'll run this query. It took around 3 seconds to write those rows, and the count of rows were 16744. And since it has the same number of rows, it should ideally double. As you can see, it has doubled. So the same table I am able to write from Spark, I am able to write from ClickHouse. And that is the true power of having an open table format, which different kind of engines understand. Moving ahead, we'll see how we can do this using OLake as well. So before that, I'll quickly exec into MySQL and show you that we have a table there as well. We have a weather table here as well with the same number of rows. So what we
And I think Saurabh covered this when he was doing the demo as well, that the ClickHouse right is really fresh off the oven. There are a couple other things that are very, very fresh there as well. Even the reads are in experimental. Experimental, if you go to the ClickHouse documentation, it clearly says that is not generally recommended for production. But as an engineer who loves to go through code and understand things, if you want to be the first user, you want to try things and break them and go fix upstream. It should be something that you should absolutely love doing. That's what we are doing. So when it is mature and everything works, maybe we are sort of people who have some experience of trying our hands on it already. So when we actually prepared this demo initially, sort of a few months ago, we met with a few bugs on ClickHouse. Some documentation was not available. So we went back, we fixed those issues in the ClickHouse source code. Those that bug you see on the top, it's merged. Then we also went back and wrote some test cases in the code base to make sure that whatever we are dependent on in future, those absolutely work and don't sort of break because of a regression. We also went ahead and, like you see here, updated docs to work with different catalogs and whatnot. We are on this, and we will share with you some other things of interest that if you are interested in, can go and try to fix it in the ClickHouse code base. Having looked at Iceberg and ClickHouse, right? I mean, as engineers, we love to go and geek out, but at the end of the day, you got to solve some problem, right? So let's look at some design patterns that is very popular in the industry around Iceberg, or even otherwise, right? These are the design patterns you can use anywhere. So one architecture that is actually quite famous is Medallion architecture. I'll briefly touch it. Uh, so you have all these integrations that come up and land up in your bronze layer. You basically have 3 layers of data. Bronze layer is where you are trying to get maximum ingestion speed, and you don't really care about the quality of data as much as on the other layers. So raw ingestion is something that is very important. We want to get data from everywhere and just put it there, like sort of showed in the demo. With Iceberg, it's just a natural fit because all the different compute engines can just come and write to the same bucket if you really want that. But that may not be the one where your queries will work the best. So what people typically do in Medallion architecture is that they have a silver layer where they filter data that they think is good. They clean it up. If there are some bad rows, if there are some nulls that you did not anticipate to land there, you can clean up all of those things and put it in probably another bucket or another table on top of it as filtered, cleaned, and maybe enriched data. And then finally, if you sort of, let's say, have 4 use cases, maybe a couple of them are okay on the silver layer, but for something, let's say ML training, I did a talk recently, I'll leave you with the links, where you absolutely want it to be sort of not waiting for any data access. We want your GPUs to be really busy. You can make a gold layer, and it is absolutely made in a way where your use case can use it in the most efficient way. Maybe it's closer, maybe the querying for this particular type of query pattern is really good in that way, right? So you can make gold layers for your business level aggregates and stuff. You can pre-process and store up the results. And it's like I said, not the only Iceberg pattern. For instance, if you look at ClickHouse, even before the Iceberg era, there was a way to do medallion architecture. There is a wonderful blog for which I have put the link at the bottom. I would really recommend you to read it. But what I'm trying to convey here is that on the bronze layer, you have so many integrations of ClickHouse that you can sort of get data from and dump it all in the sort of default storage engine of ClickHouse, which is called Mergetree. In the silver layer, you have something called replacing merge table. So you can choose an ID on which you want to deduplicate, and ClickHouse would go ahead and deduplicate all of that data, make the sort of final versions. You also have something called coalescing merge tree that came up absolutely recently. That's also a great thing. If you have some broken pieces and stuff that you want to keep in a shelf to check back later, you can use a sort of DLQ semantics. This is a dead letter queue. So the data is there, but you're not really using it. And if you care about a gold layer in ClickHouse world, you have something called materialized views or refreshable materialized views. You can make views. I mean, I think most people would understand what views are. So these different kinds of views can be made here, including materialized views, which we use a lot. It is really the engine for real-time processing in ClickHouse, and it's very easy. Anything that you can express in SQL, you can make a materialized view on top of it. And for sort of, pre-processed stored aggregates, you can use something like an aggregating merge tree, a summing merge tree. There are a lot of storage engines. All of them work wonderfully. And then that makes up your gold layer. If you think of the ClickHouse Iceberg integration in that world, how will you do medallion architecture? We have the writes merged now. So you can put all kinds of things in Iceberg table, like sort of showed you in the demo. You can do you can get things from MySQL, Postgres. You can get things from other places using something called click pipes you have in ClickHouse Cloud, or you can use the connectors to get data. You can put all of this through a ClickHouse table maybe into Iceberg, or you can just write things to the same Iceberg table again from elsewhere, or you can do insert into Iceberg table as select from wherever, a CSV file, a MySQL table, or a Kafka topic, or whatever you want. And then on the silver layer, what would be ideal is like merge tree has something called background merges. You should ideally have a way to run compactions. In a lot of the other places like S3 tables, they have compaction that works in the background. In ClickHouse, there is a item for it on the roadmap. So once this is done, then you should have that feature here. That would be amazing for making a silver layer really quickly. And for the gold layer, again, it would be wonderful if, from the Iceberg table, you can make a materialized view. So materialized views are basically pre-processed kept data. Today, you can make a materialized view where the source is another ClickHouse native table. In future, if it's not if, in future, when we have materialized views that can be sourced from Iceberg tables, that is again on the roadmap. It would be amazing for a gold layer. You can sort of keep all your backend sort of heavy queries on Iceberg. And then if you want something real quick access, then you can put it into a ClickHouse pre-processed aggregated format in ClickHouse native format, and you could get your queries working really quickly that way. Here is the link for the roadmap, by the way. Let's look at use cases, right? At the end of the day, you can sort of work with a technology and keep looking for problems, you have to look at problem and guess that, you know what, this is the perfect place where I can do an iceberg kind of architecture, and this is the place where I should probably uh, not find iceberg as a natural fit. So I have taken 3 real life use cases, quite popular in the industry. One is real time use case. You can do some sort of real time on ClickHouse, on iceberg and stuff. But in my mind, if you think of a credit card fraud detection, absolutely latency critical. Um, then the second use case that I picked up is BI dashboards. If you want to see trends about quarterly sales in a specific region or across the world or whatever, and then you can have your ML training pipelines, right? AI is the buzz everywhere these days, so why not pick a use case there as well, right? So for the first use case, real-time fraud detection, in my opinion, I would use a streaming pipeline. That's probably the way I would solve credit card fraud. If you are into ad tech, latency again is very important. You can get all that clickstream and all those things, and it's propose the right ads and stuff. Those I would do it through streaming pub sub like a Kafka, Pulsar, Nats, or Red Panda or whatever, and then you have a processing pipeline in Flink, Rising Wave, or Spark, data stream from Databricks, and then you can have the use cases covered that way. But the other use cases where Iceberg will just fit so well is you can get every kind of data, put it into Iceberg, and then you can make your quarterly trends and all those things, right? BI reporting is just such a natural fit here. And this is another thing on which I did a full-blown talk at KubeCon India um, in Hyderabad last month, I think. And what you basically are looking at here is that you have iceberg. Think of this as the silver layer, and think of this as the gold layer, absolutely optimized for your PyTorch workers, where your ML training workers are sitting. So you basically in this architecture have in-memory cached data, so that, and a very efficient transfer using something called Aeroflight. And the intent is that when you do a set of ML training and you are trying to get data, in that duration, your GPU is actually waiting, doing nothing, right? So you want to make sure data is available as quickly as possible, so your GPU is not being really wasted. GPU is actually very expensive right now, so you want to optimize for GPU being busy as much as possible. I have put the slides for the full talk here. If you are interested, you can go check it out. And if there are any questions, you can ask me. So I promised in the beginning in the agenda that I'll leave you with some things. That's a good place to start looking at open source contributions. Like I said, it's all experimental with ClickHouse integrations. So there, expect rough edges if you're building a product on top of it. For instance, there are sort of some smaller problems. I would guess these are hopefully a bit easier to fix. For instance, all the fields you will see in ClickHouse Iceberg integration now made nullable. If you want a required field, that's just not possible. While you're getting tables, you wouldn't have partitioning. These are obviously things that I'm pretty sure will be fixed in near future. If you can go and code and put a solution for this, I am very hopeful that somebody will pick up review and very happily merge it. If you have an iceberg table already staying there, and maybe it is built through some Spark-based ingestion, you can go and read through ClickHouse SQL, but you can't write using SQL on top of that table only to insert a couple of rows or another bunch of Parquet file in that table only. We spotted that while we were preparing this demo, and we put an issue in ClickHouse for this. We will go and try to take a stab. But if you are interested, please happily you can go and put on GitHub that I want to contribute here. This integration right now for write only supports inserts, so deletes is yet to come. If you have compressed metadata files, then until very recently, I think a couple of days ago, if my memory serves me right, you couldn't use those meta files to understand the data. Now it's merged and mastered, so that has gone away from the list, but it's all evolving very fastly. You have all of these things that are absolutely required by anyone, so you can go take a stab at this. Let's make a great set of contributors in open source ClickHouse integrations or OLake, really. and sort of show them that open source is actually a good model where you can get a lot of contributions. The other things on the roadmap that we are looking forward to having to build a full solution somewhere is compactions, like we discussed earlier, external introducing materialized view. That is also something that I sort of described earlier. Support for equality deletes is something that should hopefully land up quickly. But in the OLAP case, I think inserts with a good throughput and stuff work. Schema updates directly from ClickHouse would also be nice to have. They just sort of developed a brand new Parquet reader. This is probably third version of Parquet implementation, built to make sure that it performs really well. There was a question in the chat around uh, ClickHouse native format performance versus Iceberg performance. These are the things where you can see the intent that they really want to make it performant. And they have their integrations product in ClickHouse Cloud, which is called ClickPipes. There is a thing in the roadmap where they want to help you make ClickHouse native tables on top of Iceberg tables. So you have your gold layer facilitated there again. You see on the left here, there is a roadmap public on GitHub, and I have the link for it. Takeaways. Iceberg is really taking off. I can't stress it enough, right? And why not? It's no brainer. Why wouldn't you want to own your data and use the query engine of your choice there? Why wouldn't you keep your data in S3? Why wouldn't you, in the case of cloud, want to keep compute and storage separate? So it's the right solution, and that's why it's really taking off. There's a lot of buzz around. A lot of vendors are integrating with Iceberg. And so it's not only me believing that it's out there. You can see it for yourself on any roadmap these days, on any database, any streaming solution. We use ClickHouse, and that is why we are looking very closely at everything that is happening on ClickHouse integrations. And then I really believe that you have all the AI code generators, you have Cloud Code that really works so well. You have a spec in Iceberg, and then you have so many integrations, implementations of those Iceberg in different databases. You just have to look at that code, look at the spec, and use Cloud Code to generate a bunch of code, make it work really well. Make sure you understand everything. And I really think there was no better time to be a builder or an open source contributor. So check out the roadmap for your favorite database or streaming solution. Look at what's lacking in the Iceberg integration and go ahead, get your hands dirty. If there are any more questions, I answered a few. Please go ahead and put them in the chat.
Thank you so much, Shivji and Saurabh. It was indeed a very insightful session. We actually did receive some questions even in the chat. So let me just go over it. Hmm. Yeah, so actually Sanjeev asked in the chat, which we missed out to answer, I guess. As we can run demo, can you share which Docker Compose should be tried out?
Yeah, I think I have replied it in the chat.
Okay, got
Yeah.
it. Okay, yeah, got it. So yeah, okay, we have a question from Jayant. We can actually answer it live since we are on the call. So yes. He asks one question that came up to his mind is do individual engines like ClickHouse need to implement the asset behavior?
You actually, if you look at all the catalogs, they are actually a very essential ingredient in supporting the asset behavior. This is
Mhm.
something that I've been playing around a lot. Probably in future I could do a blog or a talk on this. But look at the way the catalogs are being implemented, and you will understand how asset is being implemented.
Great. Just a second. I guess we have answered all the questions. Other than that,
Yes.
Okay, yes, absolutely. So actually, yeah, we were answering the question side by side, so it just saved us a lot of time. But anyway, we are just 5 minutes left with the webinar. So if anyone asks, if anyone wants to ask some question, before I let Akshay take over, please do. Yeah. Okay, I am having some struggle with pronouncing your name. But yeah, the question is, does this support Hive Metastore?
It does support Hive Metastore, but there are some limitations with Hive Metastore. So just be cognizant of the limitations before you actually use it in production. If you're familiar with Hive Metastore and you want to play with Hive Metastore to work with Iceberg, you can definitely do that. There are some problems with atomicity, I think.
Okay, great. I think he's replying, but yes. Okay, what are the problems?
I think they are to do with atomicity of some of the data. You can just sort of Google it around. I don't remember everything off the top of my head, but I know that it's not something that I would recommend for production.
So, just to inform you, Akshay and I were sitting about this webinar, and we were discussing some questions also, we would want your insights on. So, once we are done with the audience question, Akshay would like to ask you something as well, which I am very excited to, to know the answers about.
Yeah.
But yeah,
So,
Sri actually asks, just a second, Akshay, let us just, wrap up the questions from audience,
gotcha.
and then we'll do that. Yeah. So yeah, Sri Charan asks, is absurds are good in case of lakehouse?
I am not sure. Ojha, you want to do you have a good idea about upserts?
So I think Iceberg V3 did some improvements when it comes to frequent updates. So that should solve for some issues that Iceberg V2 had with upserts. Like it was not very performant, but V3 has done some work, and I think it should be good enough for your lakehouse use case.
Yeah. But anyone in the OLEC team, if you guys know a better answer, you can. Yeah, I think there are a few.
Yeah, I
Mhm.
think Ankit from our team is replying.
Yeah.
So yes, we'll let Ankit reply about this question. In the meantime, Akshay, please, the
Yeah.
floor is yours.
Yeah. So most of the questions that revolve around is like you have a great experience around the ClickHouse and everything, and you have adopted it in your company as well, right? So what was like coming to the numbers? What was your biggest business benefit, or how did it help your organization in the long run, or everything? So like if there are new organizations over here, they want to adopt this complete ecosystem that we have seen, like Apache Iceberg, the ClickHouse, and the OLake all coming together. What do you think, considering ClickHouse would be the biggest business benefit to you?
Sure. As far as ClickHouse itself independently is concerned, right? We absolutely love it. The reasons being, it's very easy to get started with, right? Typically, as developers, you want to build your application. You don't want to end up spending all your time fighting the database, right? That's not what your business is looking for. So you can literally download ClickHouse right now. Within 2 to 3 minutes, you will be able to make a table and insert data into it. So it's just so easy to get started. Also, a lot of OLAP nature of database, OLAP kind of databases are very complicated in terms of setups and stuff. It's single binary. You can download and you do a dot slash ClickHouse. It just works. It's very fast, right? If you look at the throughput numbers, the amount of throughput it can get out of a simple hardware, it's really good. You would see that there are a lot of talks if you just go looking around on YouTube, why ClickHouse is fast, and there are some very good insights. Like if you would just look at their cache implementation, their hash table implementations, there are so many implementations inside that have evolved over time, and there are actually a lot of reasons why that happens. And third, I think this is used across the industry by so many enterprises today that we have all the open source streaming systems and databases that we have used over time. This is one where we have gone 2 years, and in the sort of all the bugs that we could find in the interim, we just went ahead, looked for it, and found a configuration. We changed the configuration. It just works like a charm. So we never found a rough edge as far as our production workloads were concerned, right? Iceberg itself, to me, I think while there is a lot of buzz, I think there is some room. There is a lot of room for adoption to sort of take off even more. And I'm very sure for how much integration is being written on right now. And like for instance, take the case of OLake that we should have seen completely in the demo if the demo goods were sort of happier. But we have tried it ourselves last couple of days, and it just worked like a charm. There is a UI, there is a CLI, there are all the other integrations. So I'm pretty sure it's getting much easier to manage. And while there are sort of very big installations where Iceberg really works well, Netflix uses Iceberg quite a lot. There is a talk online for the ClickHouse folks using Iceberg. There are a few more. I think there was a good talk on the OLEC meetup last time as well, right, about adoption. So Iceberg, I think, is taking off. We have a few use cases internally that we are looking to solve with Iceberg. But at this point, uh, we are really doing POCs, playing around and learning. We want to wait a bit more, given we have a huge amount of customers. A lot depends on everything being absolutely perfect before you push it out in production. So at this point, we are really, as engineers, sort of running around, learning things, and sort of getting our hands dirty. So that's where we are. Yeah.
So yeah, like you answered my next question pretty well as well. Like I had my next question lined up of how Apache Iceberg is going ahead and being adopted in the open tutorial formats. But yeah, pretty good on that. Like we have been seeing some good improvements from the Netflix side, and also like I was covering around the Airbnb. They have also got some really good savings up there. So we are slowly approaching to the end of the session. Let me just go ahead and quickly share my screen. Yeah. So, Harsha, is my screen visible, right? Yeah. Okay. So, guys, first of all, we would like to thank our speakers, Shivji and Saurabh, who over here went ahead and provided their time around for the session, and at the same time educated all of us that what are the recent updates in the data engineering field. Not only that, we also got to see some really cool demos. Pretty much like the how the thoroughly the demo was covered and with the various commands and everything going on. And yeah, as Shivji said, like we need to pray to demo gods much better next time. But yeah, so far so good. I stated I'm working as a DevRel over here at OLake. Won't leave you guys stranded. We would be pushing our complete blog on this, so you can follow a complete step-by-step guide from the insights of Saurabh and Shivji, of course. So more on that later. But at the same time, let's just go ahead and these are the various channels we prevail through. So if you guys are interested, you can go ahead and experiment with OLake and the various things we have implemented. So you can go ahead and experiment with OLake UI as well. So one of our offerings. So if you are someone who doesn't know code, are not much on the technical side of things, you can just completely independent to go ahead and experiment. So make sure you guys do that. And then we have various docs and quick start to help you guys through. And of course, the Slack channel, we would slowly pushing on to the numbers. And fortunately enough, if we have all of the attendees over here join, we would be getting a number of 3,300 members that would be soon joining towards our Slack. And as we have stated, 1,000 as well, we have reached 1,000 stars on GitHub very, very recently. So thanks a lot to the various contributors that joined us over that path. And yeah, a really great session. Something I pretty much liked was also the real use cases and everything around that. But yeah, the more on that later. We have the OLake community week going on, guys. So make sure you are tuned in for that. And tomorrow we have our OLake community call. So that's where we want to be pushing all of our recent updates, whatever we have done in the past coming months since our last community call. And we have a lot of interesting things revolving on from how you can deploy it towards Helm chart and how you can implement incremental filtering and other features you would like to keep in a curtain for a bit. More on that later. If you guys have scanned the QR codes, you can go ahead and do that. Or if I will push the links through if you want, you are completely allowed to do that. So let me go ahead and share. Yeah, so you guys can go ahead and check the complete OLake and how you can go ahead and connect towards on GitHub, and at the same time you can connect with us on our Slack, so you're completely independent to do that. So we're going to be slowly waiting until the times if you want. You guys can have a quick conversation or anything if you guys are interested about it, you guys can do that. And also here's the OLake Slack community. So guys, feel free to join over there. I loved everything, the session and everything around. So I have the Harsha have sent the OLake community meetup. So feel free to join there. We will also be joined by Shivji and Saurabh there. Fortunately, Saurabh might be busy tomorrow. I guess he has some plans, but no worries. Shivji would be there to go ahead and give his insights or whatever updates he has. So feel free to join there. And as again, I would be hosting that too. So see you guys there. So that's all for the session. See you guys there in our next community meetup or in the next session we have planned at September 4 with Arsham. So more on that later. Okay, guys. Thanks a lot. Bye-bye.
Thank you so
Thank you,
much.
guys.
Thank
Thank
you. See you again. Bye bye.
you. Bye.
Bye.